that I'm pointing to? Is it primary, secondary, tertiary, quaternary? It's only attached to one other carbon.
Primary, right?
It's primary. What about this one?
Secondary.
It's secondary. How about this one?
Secondary.
How about this one?
Primary.
Primary. And it's attached to this one, which is a secondary carbon. That's where we get the name sec-butyl,
Oh.
right?
Okay.
So now we got a number. We could number starting here, 2, 3, 4, which would give me 1,1-dimethyl. Sec-butyl. So this could be, if I did it this way, it would be 2-sec-butyl, 1,1-dimethyl cyclobutane. If I numbered it that way.
So you are talking about in like the terms of the alphabet, even though it starts with the S, you count the butyl. Okay. I think I remember you saying that.
Yeah, butyl first over methyl. And you'll notice that I kind of confused that's why I had to do the second part, it's a little separate. Or we can number this way, 1, 2, 3, 4. And that would give me 1-sec-butyl, 2,2-dimethyl cyclobutane. Which one's correct?
I don't know, because on the butyl, for the methyls, the first one, the methyl has the lowest number.
Okay, but what do we want to do? Don't get confused here. We want to give the possible lowest number to all of our substituents,
Oh, okay.
right? This gives the lowest possible numbering for the most substituents. I've got 3 substituents. This gives me 1,1-dimethyl. This gives me 2,2-dimethyl. So overall, this has a higher set of numbering in the numbering system than the first way we numbered.
Because there's 2 ones.
Yeah.
Okay.
Yeah. You want to try to minimize the location numbers for as many as you can. Does that make sense?
That makes a lot of sense.
I have a question. It's kind of more of a hypothetical thing. So it's an alkene, so it's double bonded carbon, and I'm trying to figure out if it's trans or cis. That's what I'm kind of thinking. So say like one of the carbons is attached to 2 carbons over here.
What is attached to what?
2 carbons. Right, and the other one's attached to 2 hydrogens over here. Would that still be cis, or would it be something else?
You tell me.
I mean, I would think it would still be cis, because...
So what I've drawn right there, is there even cis or trans?
No.
I can't determine a difference in priority, can I?
No. Okay.
If I swap these groups, nothing changes,
Okay.
right? If I swap these groups on that carbon, nothing changes, right? But if I look at this one, right, if I swap the position of these groups, things change, right? If I swap that, it changes. If I swap that, it changes.
Okay.
But if I swap these or I swap those, nothing changes. It's still the same thing. There is no cis or trans.
Okay. That makes sense. Thank you.
Okay. Yeah.
On number 18, it's 438.
Number what?
18, but it's 438. It's like, has a star by it, but
Question for chapter 4?
yes, 4.
438.
And it has A and B.
Mm-hmm.
That one tripped me up, but I know the like similarities and differences. I think I got A because they have the same molecular formula. And they're both trans. But when it says on B, assign the configuration of all the applicable double bonds,
Mm-hmm.
that's where I don't know where to start.
You have to go through each and every double bond and do what we just did
Okay.
and assign priorities to everything. Now, I can't, I'm not gonna draw this on the board,
Okay,
but I'll draw a piece, okay?
okay. Because isn't it, would just be kind of repeated, right?
Well, yeah, but you gotta do it for each one. Okay, so we'll just take that piece of the molecule, right? So you're gonna have to take each carbon of the alkene and ask yourself, is it cis or trans? Or E or Z? Right, so we're gonna have to assign priorities. So let's look at this carbon. This is a carbon, this is a carbon. This is a carbon attached to 3 hydrogens, this is a carbon attached to another carbon and 2 hydrogens. Which one's high priority? This one or this one?
The 2 hydrogens.
This one, right? So this is high, this is low. Now I gotta look at this one. Carbon, carbon, can't make a decision, right? What's this carbon attached to? All carbons. So it's got 3 carbons. What's this carbon attached to? 2 carbons, 1, 2, right? And then a hydrogen. Which one of these takes priority?
The 3 carbons.
This one. Yeah, so it's high, low. We look at the double bond and we see that the high are on the same side, so this is a Z alkene. And then we go and do that for each and everything. Got to do it all the way through. Yeah.
Okay, so why would the CH2 be higher priority?
Why would this be higher priority?
Yes, sir.
Will you agree that this carbon is only attached to hydrogens?
Yes, sir.
Okay. Will you agree that this carbon is attached to a carbon
Yes.
and 2 hydrogens? So when I look at these, carbon outweighs hydrogen. That's why this takes higher priority.
Okay.
You got to go out to the next set of atoms. Got about 10 minutes. Maybe a little bit more.
I
What
think
else?
you covered most of the things I was struggling with now. I think I just gotta get confidence, like you said.
Yep. You got good notes?
I've been like rewriting them. Because in my notes in class, I'm like scribbling everything that you say. So I've been rewriting them and trying to highlight.
So do you go back and watch the videos?
I have my plan. That's for Sundays. Sunday is video day. But
That's a lot of video.
I know I might just separate it into 2 days.
So one thing that I do, I mean, it's a good thing to take notes in class because that's when it's going to be the freshest. Right? But if you miss something, you need not panic because you're going to get my audio recording at least, right? I mean, you'll get a little video, but you'll at least have the audio recording of what we have.
Okay. I've been trying to write a lot of notes about like the relationships in like acidity because I feel like there's so many different things, like with the resonance and the inductive and all that.
So let's go through that. What effects are there for acidity?
There's electronegativity.
Which is called what effect?
I don't know, I just put electronegativity. I don't know what it's called.
Electronegativity is one of, it contributes to an effect, but we don't have an electronegativity effect.
Oh, well, are there 2 effects, inductive and resonance? Or are there more than one?
There are 4 total effects.
Oh, okay. I think I missed something.
So you said inductive, and inductive has to do with electronegative atoms.
And like the polarization of the
Yeah, so for example, if we compared the acidity of trifluoromethanol versus methanol, this is more acidic because the fluorines are pulling electrons to themselves, right? And that puts a partial positive charge on that carbon. And then when we look at the anions, right, because we always look at the anions to determine stability of acids, that negative charge is going to be close to a partial positive charge. Is that a good thing or a bad thing? opposite charges attract, right? So that should be a good thing. However, when I do this here, carbon and hydrogen have essentially the same electronegativity. So there's really not a partial positive charge on that carbon. So this negative charge isn't sitting next to something that's partially positive. So this is going to be less stable than this.
Okay, so with the inductive.
That's the inductive effect.
So with the inductive, you're gonna look at the formal charges and
Partial charge.
partial charges, and look at the opposites attracting, right? Okay,
Yeah, so there's the inductive effect.
okay.
There is the resonance effect, which is looking at things like acetic acid versus ethanol. And again, we're going to look at the anions, right? I can't draw any resonance structures for this, but I can draw a resonance structure for the acetate anion. And so this one is more, I shouldn't use a check mark. It's a check, not an X. This one is more acidic than that. Ethanol has a pKa of around 16. Acetic acid has a pKa of around 4.7, 4.8. Acetic acid is much more acidic than ethanol, which is what we drew there, because of the resonance effect.
So for resonance, you look at the
Stability
functional
comes from the fact that we can draw resonance structures.
Okay.
Yes. Yep. We also have the element effect, which, as I mentioned in class, people confuse with the inductive effect. Okay, so I know that methane, for example, is less acidic than water, even though carbon is on the second period. Oxygen is 2 over, right? So as I go from left to right, acidity increases. That's the element effect within a period. And it's because if I look at the anion, right? This is a negative charge on oxygen. This is a negative charge on carbon. Which one's more electronegative? Oxygen. Right? Oxygen's more electronegative. It's going to handle that negative charge better than carbon will. Stronger acid.
So with
pKa of about 50, pKa of about 16.
So with the element effect, notice like the groups, the trend of the groups, right?
Well, there's two pieces to it. There's the period effect, which is what we described here, but then there's also the family effect. Right, so the period effect is in a period, like in the second period, as I go from left to right, acidity increases. But as I go down a family, acidity increases. So for example, HF is a weaker acid than HCl, is a weaker acid than HBr, is a weaker acid than HI. Just like in the oxygen family, water is less acidic than dihydrogen sulfide. Because as I go down the family, the acidity increases. Does that make sense?
Yes. And what was the fourth one?
What did we say? Oh, and then the hybridization effect.
So is that where the electronegativity comes in? Where does that go in?
Well, that came in
With the element?
with the element effect and with the inductive effect.
Okay,
But,
it's for both, okay.
right. So, for example, alkynes, right, are more acidic than alkanes because these have different hybridizations. This is sp hybridized, this is sp3 hybridized. So molecules that have a hydrogen on an sp hybridized carbon, those are going to be more acidic than hydrogens on an sp3 hybridized carbon.
So
Why is that?
is it because of the amount of groups bonded to carbon? Like,
Not the amount of groups bonded to carbon, it has to do with the hybridization. So if you think about sp hybridization, SP, it's one S and one P, right? It's 50, the new hybrid orbital still has a lot of S orbital character to it. It still looks kind of like an S orbital. It's 50% S, if you will. And the S orbital, remember, can get electrons really close to the nucleus. Well, if we have the anion and it's really close to the nucleus is positively charged, so that should be a good thing. An sp3 hybridized orbital looks a lot more like a p orbital than it does an s orbital. It has 1 part s character and 3 parts p character.
Okay.
Okay? Can a p orbital get the electrons close to the nucleus? No. Because a p orbital, remember, looks like this. And there's the nucleus where it's 0 chance of having an electron in the p orbital. So an sp3 hybridized orbital looks more like a p orbital. And so the electrons can not get as close to the nucleus as they can in the sp hybridized carbon atom. So that's the hybridization. What else we got? Only 2 brave souls showed up today.
I thought it was just gonna be me. I think a lot of people work on Saturdays, so they're putting up rounds.
I understand. I had to work when I was an undergrad too. It's one reason why I record them, but
Yeah. Also, you might not can tell me this, but you said that it is material covered from the first day of class as well. So that first PowerPoint, did you mean like the general chemistry stuff or like the class? Everything. Okay.
everything that's been covered technically could be there.
Okay. Got it.
Now, am I going to ask you stuff about the syllabus and stuff? Probably not.
Yeah.
But that first day, we talked about the history of organic chemistry a little bit. We talked about how organic chemistry became important. We talked about where carbon came from. We started talking about equilibria. We started talking about those types of things on that first day in that first set of PowerPoints that you didn't have a reading assignment. So I'd recommend you go back through those PowerPoints.
Okay. I think I feel a lot better.
Well, good.
Doesn't come easy though.
Not supposed to.
Chemistry. I told myself in high school that I would not do a major that had chemistry because I took
And here you
just
are.
regular chemistry and I was like, no, I'm not. I can't do this.
Sure you can.
And
What's your
now-
major?
Nutrition. So now I'm like, well,
Everything nutrition is chemistry.
yes. I'm in A&P also, and I'm actually really glad that I took it at the same time, even though those are these are two difficult classes. I'm glad I took it at the same time because, like, on the first day, I have your class and then I have A&P, and he would be talking about stuff that, like, the acids and bases and stuff.
Who's teaching A&P?
Glenn McCombs. Yeah,
I don't know him.
it's
I don't know him very well, at least.
actually not as bad as I thought it was going to be. You just have to study like a pretty.
Which one is this, 250 or 251? The second semester or the first semester of A&P?
This is my first semester of this. I
Probably
think
250.
it's 250. But some of it, like, he was teaching a little bit of organic chemistry in like chapter 2 of it, and it was like I went from your class to that class, and I kind of already knew my brain was in chemistry. But sometimes he tries to like separate chemistry from A&P, and that kind of confuses me because I think he thinks that like people who've never taken chemistry would be confused. But like he was separating, like you can't say, like I know how to draw a Lewis structure, and I just count valence electrons and all that. And then like with covalent, ionic, like you learn like non-metal, metal, but he was like separating that. And I was like, in my mind, I don't think of chemistry as like metals and non-metals. Like, I think of it as like in your body. Chemistry is like in your body. But he was trying to separate it, and it was kind of confusing. But I was just like, I'm just gonna go by what I know about chemistry from the beginning. But he's a good teacher, he is. But
Good. Well, I mean, it could be,
I just don't think of it as separate. Like,
I don't think A&P has a chemistry prerequisite, does it? Or does it have a chemistry 106?
there's a lot of people in there that have never taken a chemistry in their life, and I'm like, I don't know how you're doing that. But he
So
was
is he
trying.
spending enough time giving you just what you need in chemistry to kind of cover some of
Yeah, he was teaching Lewis structures like covalent and ionic bonds, and he was drawing the atoms and drawing the circles and then like connecting it like CO2, and he was like, how many covalent bonds are in this, whatever. But when I do that, I just draw like the Lewis structure, and I see that, you know, you have double bonds and stuff. But I was just thinking, I was like, he's kind of making this a lot more complicated than it should be. But to someone who's never heard of the Lewis structure or anything, I can see how that would help. But
Yeah. And what's your major?
Forensic science. I know what you mean because I had Dr. McComb for Bio 1 last semester.
Oh,
He
yeah.
tried to teach chemistry in Bio 1. It was very confusing. I was just sitting there like, because I remember all the high school chemistry, and I was like, I have no idea what's happening
Yeah.
right now. It was very confusing.
I was like, why? I think that he thought that people think chemistry is like explosions and like non-metals and metals and like, I don't know, you don't think that that stuff is in your body or whatever, but I don't think, like, when you're talking about electrons and protons and neutrons, like, you know that's in your body, so, but,
We're made up of matter. Matter is chemistry.
yeah, but
Yeah.
his test wasn't actually that bad. But
All right, well, thanks for coming.
thank you so much for taking your time, your weekend to do this, I appreciate
You're
it.
welcome.
All right.
Get this posted as soon as I can.
See you tomorrow, 2 o'clock, right?
2 o'clock if you want to come.